Hi everybody. Today's session is going to be on cohesion in software engineering. Before getting into knowing on cohesion, let us know something about modularization. What is modularization? So dividing your entire software project into different small modules in such a way that executing all the small modules will result in the execution of your entire software project is called as modularization. To put it in simple words, it's like dividing your entire problem into sub-problems, and you're going to solve the sub-problems separately, and finally you integrate all the sub-problems to find out the solution for the entire problem, and this is called as modularization. So simply you're going to divide your software project into several modules. So how are we going to divide your software project into several modules? So you have certain criteria for doing it. One such criteria is to analyze the cohesion among the elements in the same module. Okay, so depending on the cohesion, so cohesion is nothing but the binding between the elements in a module. So you have to analyze the binding between the elements inside a module to find out whether it can be modularized or not, or how it has to be modularized. So modularization criteria includes actually two concepts. One is coupling and the other one is cohesion. So now we are going to talk about cohesion. So cohesion, as I told you before, is going to tell you about, or is going to measure the binding between the elements within the same module. So to modularize or to make a module out of your entire software project, the elements bonding within that module should be very strong, right? A strong cohesion is required for making a module. So a module is made as a module from the entire software project when the binding of elements within the module is very strong. So we need very strong cohesion. So now let us find out the various types of cohesion, which is ranging from the weakest cohesion to the strongest cohesion. Remember, we need the strongest cohesion because we need stronger binding of elements within a module. So we need the strongest type of cohesion. Now let us see the various types of cohesion which range from the weakest to the strongest, but we need only the strongest cohesion, and the strongest cohesion is more preferred, we can say. Now the various types are as follows, as listed in your screen: coincidental cohesion, logical, temporal, communication, sequential, functional and informational. So this is being categorized based on their strength or based on their binding. So coincidental cohesion will have the weakest cohesion, and informational cohesion and the functional cohesion will be the strongest among the cohesion between the elements. Now let us see one by one. The first one is coincidental cohesion. So coincidental cohesion occurs when the elements inside the modules, they don't have apparent relationship to one another, but they are just put together inside the module. So even if you separate the elements, they'll be functioning properly, or there'll not be any changes. If that is the case, then it is called as a coincidental cohesion. As the name suggests, the elements are bounded together only coincidentally, and there is no particular purpose of binding between the elements. So which means that taking away the elements separately will not make much difference. So this type of cohesion is called as coincidental cohesion, and since this doesn't encourage more binding between the elements, this is the weakest form of cohesion. And next comes your logical cohesion. Logical cohesion implies there is some relationship among the elements within the same module. So for example, all the input operations are put inside a module. So this module has a logical connection between the elements. So element 1 will get the input for A, and element 2 will get the input for B. Just for example, in that case, every element of the module is having some logical relationship, and so this is termed as logical cohesion, and there is a little binding of elements between the modules. So this is also categorized under weaker cohesion, but still it has some logical relation between the elements of the module. Now let us move on to the next cohesion, which is called as the temporal cohesion. So in temporal cohesion, it also has several disadvantages as your logical cohesion, but it performs some particular function, right? So one module is fully dedicated to some kind of particular operation. This type of cohesion is called as temporal cohesion. For example, all the initializations are put into some module. In that case, the elements may not have a parent relationship, but everybody is doing the same kind of work. Okay, so in that case it is called as temporal cohesion. So coming to communication cohesion, all the elements of the module will work on the same set of data. So there is some relationship among the elements. So all the elements within a module are going to make use of the same set of input or output data. In that case, it exhibits communication cohesion. Okay, so there is some relationship between the elements of the module. So the module is tightly bound. So which means that this is a strong type of cohesion which is preferred for making up a module. Okay, and then comes your sequential cohesion. In the sequential cohesion, the elements, the output of one element will become the input of the other element. So one element is completely dependent on the other element for its input or output. So in that case it is called as sequential cohesion. So next comes the functional cohesion. Functional cohesion is the strongest of cohesions, which means that the elements in a module are completely dependent on each other. So they are related to the performance. Without one element, the other element will not be able to function. If that is the case, it is called as functional cohesion, and this is the strongest form of cohesion, and this bind the elements within a module very tightly, which shows that the cohesion is the strongest one, and such type of elements has to be put together in a module. So this is called as functional cohesion. And next comes the informational cohesion. So when complex data structures and several routines to manipulate the data structures are put into a module, then it is called as informational cohesion. This is also the strongest type of cohesion. So here, when you look into the strongest types of cohesion, you can note that all the elements are bound together functionally or information wise or sequential wise. They are all bound together. So in that case, we can put all these elements together and form a module. So that is the actual requirement. So how are we going to form the modules? We are going to form the modules if the elements exhibit stronger cohesion, if they are functionally dependent, if they are informationally dependent, if they are sequentially dependent to one another, then they exhibit strongest cohesion and they can be put inside a single module, is what is explained here. Thank you.